This is a recording of the GLUT3 transporter. I have the software package VMD opened in two windows. On the left we have this PDB file open where I'm only showing the chain A that was in the original file. And in the right hand panel we have this is the open out confirmation on the right, and this is the outward occluded on the left. Hope I have that right. Anyway, what I've done is the 9 is on the left, outward occluded, open out on the right. And these are the amino acid residues from our PoreWalker, the top two, and then the bottom row are the numbers of the residues that I observed in our simulation forming H bonds with the glucose. So I have loaded each of these separately, and then under graphics and graphical representations I've created 3 representations of each. I'll pull this one out so we can see it. And on the first one I have all of the residues shown in the new cartoon. That's these ribbons, and they're purple because they are alpha helices. I have them colored based upon secondary structure. The second set are all of the residues coding the pore. Copied from Word and pasted it in here. This is worded. I'll go home. You type res ID. There are many different types of selections that you can use here. For example, I'll show you chain. There's only chain A that's in here. As I said, there might be in the simulation we have W for water, O for the glucose, P for the protein, I think L for the lipids, and then there's sodium chloride and things like that. So all those chains and fragments, seg IDs, whatever it is, and then there's res ID here that I use. You would put in the residue number. So I'm just putting in the numbers with a soft space between them. I just copy them from Word, paste them in here after the res ID word. And you see that I'm showing those right now in licorice. Back here under draw style, I'm going to change that one to surface volume as well, or quick surface, so we can see the entire pore suspended within the alpha helices. Then we'll come over here on the left and do the same. I have to pull this up here to see it. That's the one on licorice, so we want to do the quick surface. Okay. So now what we're seeing is in the open outward and the outward occluded, the quick surface of all the amino acid residues that PoreWalker identified, right? And now I'm going to change those back to just the licorice view so we can see those amino acid residues suspended along the length of the entire molecules, and then only the residues for the hydrogen bonds will be in the surface view again. So I'm going to do this for the rotation, and if we have time left I'm going to tilt them down so we can look at the top, and then tilt them up so we can look at the bottom just before stopping the video. So again, over here we change this back to licorice, and then this one change it. Challenging my memory with all these things going on. Not my memory, but my computer's memory. And back to licorice. Come on, there we go. Note that these are mirror image. It just happens to be the way the files showed up. Coming around over here, I think, is the carboxy terminal right there, and notice it coming around from the left on the opposite side. So that makes it a bit tricky. But anyway, we just want to see that obviously these are distributed in the outward occluded. The ones that form the hydrogen bond with the glucose appear to have a different placement within 3D space, even using our mirror image minds, right? There's something about angles in positions relative to each other, at least. You can see, obviously, the open out, things are separated more at the top. So let's go ahead and do the top view. So this is the outward occluded. And this is an important loop right here. You can see that it's already kind of in a different position. However, they don't look mirror there, but they're supposed to be mirror image, but that might be due to the conformational changes. Okay, let's change to the surface on everything. I think you can see there's more of a channel in the open outward. You can look almost all the way down through, whereas here we can't quite position it. It's outward occluded with using the surface, right? Anyway, let's do the full surface of the residues lining the pore. Quick surface. That's the top view of the open out, and quick surface. Okay, so these are just the pore lining residues for each of these. So I think we can see we have an open outward and an open occluded in the appearances there. Now if we come and we do the entire molecule in quick surface, our colors are going to kind of get mixed because we're using the secondary structure to color this one, whereas it's just the name of the amino acid residues. For the other quick surfaces, you see the word name up here, so it's coloring based upon the name of the amino acid residue in that one. When we change this one, it's going to be the secondary structure color. And quick surface, there it is. But just the same, I think you can see more of a open-ended top of the funnel appearance here when it's open outward, and that tends to disappear or become distorted, at least, right? So does this correspond to this, this to that, and something in here to this region? Right? This just seems to be very much the same, but the patterns obviously are different. So let's go to the bottom. So what do we have coming out? That looks pretty well closed. That looks pretty well closed. Let's back them up. Oops, I don't need that. I need you to come up here and go back to new cartoon. And you to come here, back to new cartoon. Just leave that one active. This is, well, this is oriented there and this is oriented here. This is the C terminal and this is the amino terminal. But notice the red, green, and blue axes. So blue is going that direction on this one and directly to the left on that one. So these are the same axes within the proteins, just happen to have them reoriented so they look a bit similar. Right? So it is a bit challenging to compare one thing to another. Now let's take off another layer of the quick surface. These are the full residues. Let's take these to the licorice. And the same over here. Boy, it just wants to do that, doesn't it? And here to the licorice. Why don't I just do that? So which one did I just change to the licorice? Oh, wrong one. That's why I didn't change much. So we want that one, new cartoon. This one that has all the residues. One. Okay. This one back to licorice. There we go. Now we're at comparable views. We can find kind of similar landmarks. I'm not going to try to rotate this to match that, but anyway, we're seeing pretty much an occupancy of the exit. This would be if we're standing inside the cell, looking up at the bottom of this, waiting for glucose to come through. Certainly seems to be occluded. And we'll change these now to licorice to get a view of just everything in licorice before we end in licorice. So what I'm doing in Microsoft Excel is I have used the concatenate function to pull these two together. I colored them orange. This is the complete list. Then in the study for the hydrogen bonds, concatenate. Somewhere I have put these together. There it is. I put them together, sorted them to find out how many of the total list that are lining the pore have not been observed to form hydrogen bonds. So you see those on the left column. The orange ones I pulled in where there was an orange and a white. We had a match of those lining the pore where we observed them forming hydrogen bonds, and then on the right, those forming hydrogen bonds that were not identified as lining the pore. So that's the point of the analysis we are at now. Got just a couple minutes. Let me show you how I load a movie. Let me just quit this one and get rid of this molecule. Load a new molecule. I'm gonna have just enough time to do this, I think. Go to recent places. Well, this won't be the most exciting movie, but anyway. I'll have to do that at a 20 stride here because there's so much data in it. And then I go right out and get this PSF file, load that. And while it's loading, we're seeing the simulation run. I got just another minute. So I can change this to chain P while it's loading. That's only the protein. Then I can change it to our new cartoon. I can create a rep, do chain O. That's only the glucose. Change that to, I'll change it to this one so you can see it in there. We'll see if we can zoom in. Just a few seconds left. Scale, go in. You see it within there, right? And run then you can see it bouncing around, right? I can do that to chain W, just as we're about to finish up. And those are the water molecules in there. Right? So enjoy watching the water molecules bouncing around in the channel as our last moments pass away. Oh, it disappeared. Let's bring it back. Whoop, not scale. Translate, pull it back in. There you go.